right. Good. Yeah, I think so. I hope so. I hope it's recording the right thing. All right, well, I'll go ahead and get started. I'm the unfortunate guy between you and lunch, so I'll try to run through this a little bit quicker. But my name's Craig O'Neill. I guess I'll let our moderator here set the introduction.
I did get a bio from for Craig, so my apologies. I'll really let you do it. 20 years of industry experience, 15 in OGI, and he's with Teledyne. So,
Yep.
Craig, it's all yours.
I appreciate it. And then I'm here with Yoshing Zing as well, who is a partner of ours in Providence Photonics. And Yoshing, in the essence of time, I may pull off on your lofty accomplishments on your mind. But Yoshing's here to answer any technical questions on some of the analytics. And FLIR, on full disclosure, FLIR has a public minority share investment in Providence Photonics, and going to be associated with them. But one of the things I want to talk about is, a couple of years ago at this show, we talked about going from cooled to uncooled. What does that do? We really were the first ones to come out with a true commercial methane, low-cost detection solution. The advantage of that, and the main one is cost, right? Being able to take this, it is methane-centric and not broad VOC, like our cooled handheld solution, which is layered into EPA regulatory refines. But a huge advantage of that is that it requires less maintenance, so that when you begin to look at continuous monitoring, you don't have quite the constraint as it relate to maintenance of a cooled system in a long-term application. But there are other fringe gases that we can visualize with this, with a variety of ways to change the filtering. But the reality is, here and in this industry, we'd be focusing on our methane. In looking in there, you look at a little bit more of the industry and what they've done to drive this. Some of the coalitions that are out there, and why would we move to an uncooled? Why would we move to a low cost, a newer technology? And why optical gas imaging in general, things like the OGMP, looking at source level. And we'll talk a little bit about source level detection and optical gas imaging, in particular in a continuous monitoring compared to other technologies. You look at the OGCI and their climate investment stuff, they're looking at scale-up technologies, and it makes it much more difficult, for scale-up technologies when you have that higher threshold, something that can't operate on a longer-term scale. But a lot of this has been more of some of the oil and gas industry and some of the focus on methane. There are some industry partners or industry operators out there. These are all direct statements from annual reports, annual shareholder reports, and BP specifically calling out, fixed optical gas imaging cameras in deployment and looking at a long-term 50% reduction in methane intensity. Chevron has also, in their annual report, specifically calling out and doing some investigation on new automated leak detection technologies, and with optical gas imaging being included in some of those leak detection technologies. And then, of course, the regulation, the new regulation that is currently under comment period review, in which they are specifically calling out for the first time ever a super emitter. That's always been a big challenge for us. We've been a technology company, and we're here to make technologies that meet the needs of the industry. Our biggest issue is nobody ever told us what the problem is, right? How big is the problem? Where is that box? What do you need to see? Well, we need to see a leak. Okay, well, define that term of what a leak is. And in 2016, a leak was for the first time truly defined in Quad OA. There was no leak definition for a broader technology, a scale-up technology like OGCI is looking for, a more optical gas imaging low-cost technology. And so this was very unique in being able to set a framework and a foundation on a true leak definition, and including the word super emitter in a regulation was quite unique and surprising, to be honest with you, from my perspective. So what do we look at? How do we look at this getting into the continuous? I like to take this in terms of what they call the SCurve Innovation. Many of you may or may not have seen this, but there is an SCurve Innovation where you move from fermenting, then you're going to have a technology takeoff. Then at some point in time, you're going to have that maturity level of that, and then you're going to have a discontinuation of technology. Now, I'm a bit selfish, and I hope the discontinuation of optical gas imaging in many different ways does not happen for a long time. But at some point in time, we understand. And if I look at this in the term of a S-curve, there's always another S-curve following the first one, right? There's always an innovative technology going out there. If I think of this in terms of our technology, FLIR's technology specifically, and I look at where we are in optical gas imaging and handheld, at some point in time, there is going to be potential trail off of that. There potentially could be that, and we see that optical gas imaging. I expect it not to happen for a while. It's tailored into quad O, B, and C, and specifically into the 10 kilogram per hour alternative technologies definition. But I don't know where that is. But what I truly envision at some point in time, 2 years, 5 years, 20 years, I don't know, that S curve of innovation moving away potentially from truck rolls and people and moving maybe into more of a continuous aspect. And I don't know when that is or how that is, but that's just something that I would envision if I look at an S-curve of innovation, how it addresses various markets, not just ours. And then I look at our technology in general, continuous optical gas imaging, to be transparent. We work with competitors as well. We work with some companies out there where we've even combined with other continuous optical gas imaging and comments for quad O ABC. As it relates to the public comments out there. But the main thing I look at is if you look at the ability with my technology and the optical gas imaging and the uncooled lower cost, what is that? And I think about situational awareness. And where do we go for definition? We all go to Wikipedia. It's just easy to get to. But Wikipedia defines a situational awareness. One is the perception of the elements of the environment. If you think about the true words inside there, it's perception. True situational awareness in step one, perception is not reality. A lot of the technologies that are out there in emissions mitigation, they provide a perception of reality. They provide a perception of what's truly happening on site. And if you skip to and go to the second one, the comprehension. If you look at comprehension, you have to comprehend what's happening. You have to be able to see what's happening in real time and not just in a snapshot. You have to see what's happening realistically, and optical gas imaging gives you the opportunity to comprehend what's happening on that site. And when you can comprehend and not just perceive, you have that projection of actually a future status, fixing what's happening because you now know what the problem is, and being able to have all the data necessary to actually fix this. And they even quote Wikipedia that inadequate situational awareness is equal to the accidents attributed to human error. And that's, in my opinion, that's really kind of true. And again, these are just quotes from there. So I look at the other technologies and take another very knowledgeable person and say, a picture is worth 1,000 words, and I love the statement. And I agree. There's a lot of data that you can perceive from these images. But again, it's just perception. But if a picture is worth 1,000 words, what would a video be worth? What would a true comprehension of what's happening on site be worth? Knowing that this is a leak or this is a vent. This is an operational emission or this is a true emission. And so being able to do that and looking at other technologies in the market, all of these are picture technologies. Whether I'm a fixed mount sensor that gives me a graphical data, or whether I'm a satellite that mows the lawn, as they call it, every 2 weeks or 2 months, or an aerial, an airplane that flies over when the weather's right. It gives you the capability to have a photo of what's happening on site. Car driving around, all of these things give you that a single snapshot in time. Whereas optical gas imaging gives you the capability to know what's happening in time, to comprehend what's happening and understand where you are with the true emission situation on site. And so what we've done is we've partnered with Providence Photonics and looked at this more holistically and said, how can we bring something to market that actually solves the problem and is a true out-of-the-box plug-and-play type of solution for this? Looking at the methane focus over the last 3 to 5 years, and then tailoring into some of the EPA stuff, we've looked at providing a true gas alarm monitoring solution. Being able to take the technology that we have in our uncooled sensor. That was originally launched as a handheld camera with various lenses that are filtered to see various gases, but taking a small, low-cost, long-lasting, uncooled optical gas imaging sensor that can be mounted into enclosure, into a pan and tilt, so that it can actually do step and stare and routing with, if you will, routing on site. Being able to have that with a back-end UVMS and really powered by a true analytic from Providence, and we have the capabilities to provide that situational awareness on site, provide that comprehension of what's truly happening on your well pad. Our alarming analytic is powered by Providence. These guys have been doing this longer than anybody. I believe, and Yoshin can correct me if I'm wrong, I think that their first deployment of a true optical gas imaging analytic was over 10 years ago in partnership with ExxonMobil and in what is called IntelliRed, trademarked by Exxon. They've also have the first quantification solution in optical gas imaging that was actually commercially available in 2016. And then in 2019, we entered into a minority share investment partnership with Providence Photonics. So, being able to put the technology from FLIR with the longest realistic, champion in analytics and quantification, as far as the people that have been out there the longest in the industry making this stuff, it really gives a seamless fit. And then taking all of that with the back-end FLIR security VMS, right? FLIR security has one of the industry-leading video management solutions out there. And so they have what they call the UVMS, to be able to have, whether it be, a video, short-term video, pre and post leak, whether it be single snapshots with colorization imagery, so that you can actually see what's going on. And again, the video here, they being able to have that's where you get the situational awareness. That's where you can see what happened. Maybe that leak occurred because in the 5 seconds before, somebody popped a PFAS, somebody did something that they weren't supposed to, and you can be able to use the technology to do that. What might this look like in the field? Just a sample. This is just a random oil pad in the Permian. I will say it's in the Permian. Just a random overhead snapshot where you may have a camera mounted, whether it's here next to a tower, maybe it's off to the side, putting it either fixed mount, and if you were to put one here, and now that we understand the box, right, now we can do more studies. We're going to wait on doing those studies until we see if that box changes, because I think that there's a good chance that 10,000 grams per hour, maybe a bit of a high leak, could be considered as a super emitter. But we're going to see what's going to happen with that. And once we understand and have a better definition of what that box is, then we can go evaluate our technology to better understand exactly how far away we need to be, where we can analyze, where we can alarm, and where we can measure accurately those things, and be able to figure out, on a situation or an overhead view like this, what a setup might look like with a FLIR continuous optical gas imaging camera. In our solution, this is what we're going to have in a few, later on this year, Q2, Q3 type of time frame. Right now, we're in a field evaluation with one of the largest oil and gas companies on the globe, and we're working with them. Their goal is the same as ours, to try to get rid of those nuisance alarms, to try to get rid and filter out the things that may happen in alarm with an optical gas imaging solution, understand the sensitivity of the analytics, and we're working with a closed loop with them, with Providence and their team, to understand the sensitivity of those analytics and where that needs to be to try to reach that threshold that they desire. And once we understand that better, we can now apply what that desire is to more of a regulatory type of application in a continuous optical gas imaging. And again, their goal and ours is get actionable field results and fine tune those analytics. And we're looking at, again, later this year, to have a true solution, plug and play. You just simply take it out. All you gotta do is run wires to it and mount it. And it would be a true solution from FLIR with our award-winning uncooled optical gas imaging technology. And again, I wanted to kind of swing through this. I did not know that I was going to get the 11:45 going into lunch, so I thought rather than take time on every slide, kind of push through this a little bit quicker, and see if there are any questions on this, on the topic, or feel free to reach out to me. We'll be here for the rest of the week, and I think I have a couple of other presentations. So any questions now? Comments? Claims? Give those to you. Well, I appreciate your time. I know it's that lunchtime. I wanted to push through this pretty quickly, and just, you know, at FLIR, we're excited for some of what we have in store, and you know, we do partner with a number of other people, and there's a lot of opportunity in store for, in my opinion, continuous optical gas imaging because of the capabilities of truly understanding what's happening on site. So thank you.
Thanks, Brad.